looking at a couple of systems of simultaneous linear equations. Okay, so we have the equations x plus y equals 4, 2x minus y equals -1, and we want to find values of x and y that solve both equations at the same time. Now it's going to turn out that our solution is x equals 1, y equals 3. If x is 1 and y is 3, then x plus y add up to 4. And 2x minus y would be 2 times 1, which is 2, minus 3, that gives us -1. Okay? Now how do we get that solution? Okay? Well, maybe we can play around with this and actually discover the solution without doing any algebra. But in general, that's not going to be possible. If you go to this system of equations, you'll never find the solutions just by trial and error. I won't say never, it's extraordinarily unlikely. Okay, so how do we solve these two? Well, without going into the general theory, let's just observe how a solution could work. If I add this equation to this equation, well, since this side is equal to this side, and this side is equal to this side, what I get when I add these two sides has to be equal to what I get when I add these two sides. And when I add these two sides, I get a y and a -y, that gives me just 0. I get an x and a 2x, that gives me 3x, so all I get from this side is 3x. 4 and -1 add up to 3, so 3x is going to equal 3. So I added the equations in this case. Now you won't generally add the equations because generally the coefficients of y don't line up that nicely. But in this case they do, so we did it. Okay, now we solve this equation for x, divide both sides by 3, we get x equals 1. So now we have a solution for x. What can we do with that? Well, this solution for x has to apply to both equations, so we just plug x equals 1 into either of these equations. So somebody in class chose to use the first equation, which is kind of a natural choice, but you could equally well have chosen the second. It wouldn't make any difference in the final result. But plugging x equals 1 into the first equation, we get 1 plus y equals 4. So we write that down here. So the first equation becomes 1 plus y equals 4. Then we solve that for y. Well, subtract 1 from both sides, we get y equals 3. Okay, so now we think we have a solution. X equals 1, y equals 3. Let's see if that works out. So what we do is we plug both x and y into the other of the original equations, okay? Because remember, we plugged our solution for x into one of the original equations and used that equation to find y. We're going to want to plug that solution for x and y, the solution we have at this point, into the other of the two original equations. Okay, so we use the first equation to find y. We use the second equation to see if the equation is verified. Okay, so we put 1 in for x, we get 2 times 1. We put 3 in for y, we get our -3. And then our right-hand side should be -1. Then we verify this. Okay, well, 2 times 1 is 2, so 2 minus 3 equals -1. Do we verify this? Well, 2 minus 3 is -1. So this gives us the equation -1 equals -1, so it checks out. Okay, now that's all there is to it in this case. Okay, now we have these two equations, okay? I didn't have the negative sign in front of this, I just had these two equations. If we add these two equations, it doesn't work. Well, that doesn't always work, but most of the time it doesn't. But we have a 2x and a 2x, so it seems that if we subtract these two equations, the x's are going to go away. And that's exactly what we want. So we subtract this equation from this one. So that's going to give us 2x minus 2x, which is 0. And it's going to give us what? 3y minus a -4y, which is 3y plus 4y, which is 7y. And we did that pretty well. Okay, people are pretty good with that. Okay, then we're going to have a -5. And since we're subtracting this equation, we're going to have to subtract the 2. It's going to give us -7 because 5 minus 2 is -7. Now we did have a little trouble in some cases with people want to say that -5 minus 2 is 7. Well, it isn't, because -5 minus 2 means you start at x equals 0, you go -5 units in the x direction, then you go -2 units, so you end up at -7, okay? Anyhow, you get 7y equals -7. Adding didn't eliminate anything, we tried subtracting and it worked, okay? So then, we proceed with the solution, okay? And people work this out very nicely, except that if you had a +7 here, the solution didn't check out, okay? Now, I'm going to do the same process here, but I don't have a lot of room, so I'm going to just say, okay, that tells us y equals -1, divide both sides by 7. Now what I do is I plug the y equals -1 into either of these equations. So let's just plug y equals -1 into this equation, and out of that we get the equation 2x plus 3 times -1 equals -5. So that becomes, well, I'm not going to go through the details of solving it. 3 times -1 is 3. If I subtract 3 from both sides, I get, if I add 3 to both sides, I'm going to get -2. So I get 2x equals -2. So x is -1. I don't have room to do it, but if we put -1 in here, we get 2 times -1, that's -2. Yeah. And if we put -1 in for y, we get 3 times -1, which is -3. -2 and -3 is -5, and that verifies. So I'm just going to say plug into the first equation. Actually, I should plug into the second equation, shouldn't I? Okay? And we get, in the second original equation, forget the fact that I had this minus on here. Here's the second equation. We get 2 times -1 minus 4 times, no, x is -2. 2 times -2 plus 4 times -1, minus 4 times -1. That should equal 2. Well, you can verify that it certainly doesn't. X is -1, y is -1, I'm sorry. I was right when I plugged -1 in here, I was wrong when I replaced that. Okay, 2 times -1 is -2, 4 times -1 is -4, -2 minus -4 is -2 plus 4, and that's 2, so it checks out. Okay, you always want to do that checking step. Now there's one more thing we want to see. What if we have these equations? If you add them, nothing goes away. If you subtract them, nothing's going to go away. So what are you going to do now? Well, in this case, we could double the first equation, which would give us a 10y, and then if I add the doubled first equation to the second equation, I eliminate the y's. Okay? And that's the whole thing. We want to eliminate one of the variables, solve for the other, plug that in, and solve for the remaining variable. Okay. So, if we double the first equation and rewrite the system, it looks like this. Clearly doubling this equation gives us this. And now when we add them, we get 10x, we get no y's, and we get 27. So that x equals 27 over 10. That's what we get when we solve the equation we got when we added. Now we take that and plug it into one of the equations. Well, I chose to plug it into the second equation just to show that we don't always have to plug into the first equation. Okay? And I get this. Okay? Now, we didn't solve this equation, and we're not at the, in the first couple of days, we're not going to deal with equations that have messy fractions as this one does. And most of the time, most of the equations that arise will have messy fractions, but we're going to be concentrating on equations that have integer solutions or simple fractions for solutions, easy fractions. In any case, this is what we would get. We would solve this. Multiply both sides by the denominator 10. Clears out all the fractions. And that would give us the equation, what? It'd be 108 minus 100y equals 150. Well, we could solve that for y. Okay, so we would solve that for y and proceed just as we did, except we're going to have messy fractions, so we didn't.